Welcome. How are you?
Hello, Bulat. I'm fine. How are you?
I'm quite fascinating to see like big names that I've heard about like years and years ago, and I'm quite happy to have you here. You have a very impressive biography. I hope you would share with us this experience. And since we are talking about artificial intelligence and cloud platforms and so on, Mr. Randy Gupta will give us some introduction to Kubernetes, which is, as you might know, orchestration platform for containers like Docker images. And if you don't know what a Docker image is, then you probably should know that by now. Just go and study that. Now, I'm giving to you the platform.
Thank you. First of all, I will give a short introduction about or a short overview of the history of Kubernetes, because that helps a lot to understand what Kubernetes is and what Kubernetes does. So Kubernetes is actually a fork of Borg, which is a container platform used by Google internally. They are still using Borg, but Borg is very specific to the needs of Google. And Kubernetes is can be considered as the open source version of Borg. So let me start with the data centers. So that is not how the data centers in the mid-90s looked like. They looked more like that. So that was this is a picture of a real rack which has been used for by Google in the very beginning. Google didn't have much money to buy expensive server hardware, and so what they did was they took the cheapest hardware where they could get. They left everything away, including the housing, including power switches, and they have put everything into the racks as much as possible. Usually, you have in a server rack, you have per row you have one server. They have put in 4 servers by putting just the main board inside of it. And if you look at the picture here, you can see they have isolated the main boards with cork, and so that it doesn't cause any shortcuts. At least that was the try. In fact, many of this hardware did never work. So that means they needed an intelligent software to schedule the load so that there are only those servers used that are actually working. And if something else got broken, then the software had to be started on an entirely different server, and that was actually the how Borg was born. And Kubernetes, as I said, is a fork of Borg. What you can do with Kubernetes, as initially said, it is a container orchestration platform. But let us speak more about where you can run it first. You can run it on your laptop, for example. Minikube is a good starting point. If you have Ubuntu running, you can actually start Kubernetes with the package manager. You just run microcates, which is very easy to use. I can absolutely recommend that for Ubuntu users. You can run it on bare metal servers, as I've just shown. Actually, you just need the main boards and a little bit of power. For Kubernetes, there are so-called distributions, like Linux. You can get Kubernetes in different flavors. But the platform itself, the environment for the software is always the same. I will speak about that later on. For Kubernetes, you can get different so-called distributions. My personal favorite distribution for bare metal Kubernetes is Rancher. That makes it very easy to deploy Kubernetes on bare metal machines. All you need to have is SSH access to that, and Rancher spins up on top of that a whole Kubernetes cluster. Another very popular distribution is OpenShift by Red Hat. Red Hat is also actively contributing to the development of Kubernetes, like many more companies like IBM, VMware, etc. Even Microsoft is contributing to that, I think. Then there is K3s, pronounced Kates, and that is for smaller devices like Raspberry Pi, which is also possible to run Kubernetes with. And a very good starting point is also the cloud. Personally, I mostly work on the GCP, where you can start a so-called GKE cluster, the Kubernetes engine cluster, on the GCP, and don't have to worry about anything. You have a fully managed cluster, and then on the cluster you can run microservices, yes, but not only microservices. You can run batch processes, whatever you need to process. You can start a process, and the whole cluster take care of that. You can operate service meshes, where you have a mesh of applications that spans across the cluster. You can, for example, expand that mesh onto your edge devices, on your DC on-prem. The most popular service mesh today is Istio, but also Linkerd is widely used. Servers, you can run serverless workloads. My previous talk today was actually about Knative, where you can put a workload into Kubernetes, and if you put an HTTP request on a particular endpoint, Kubernetes will on the fly start the container, reply to let the container reply to that request, and if it doesn't get any new requests, it will simply delete it again. It doesn't consume any resources. That means Kubernetes can also be a platform for serverless workloads. With that, you're not locked into the vendor's offering, like with AWS Lambdas or Cloud Functions. You can even run virtual machines. That is what Kubernetes, what Google does very regular with Borg. Borg is actually running virtual machines. For example, if you need a Windows service or something like that, for whatever reason. You can run machine learning workloads with a Kubeflow. That is also these solutions here that I'm listing here are all Kubernetes native applications. Kubeflow, as the name implies, is TensorFlow for Kubernetes. You can then even get TensorFlow running with GPUs and TPUs, I think, as well. You can run game servers. Agonis is a very nice solution that builds on top of Kubernetes, and there you can use your Kubernetes cluster as a game server. You can also run databases with all kinds of databases. Kubernetes has the concept of operators, which is a software that sits inside the Kubernetes cluster and take care of the life cycle of a database. For example, if you need to add more nodes, or you need to decommission something or upgrade a schema, that the concept here is for databases, you usually have a human operator, and some of these tasks, obviously not all of these tasks, can then be taken over by Kubernetes operators. Basically anything that you can put into a Docker container can be run into can be deployed into Kubernetes. Actually, I don't have a presentation about Docker here, but in the Q&A session later on, I'm happy to answer questions around Docker itself. If you want to work with Kubernetes, you need to know what Docker is. In a nutshell, Docker images is the Linux userland environment. There's anything in except for the kernel. And if you start Docker, you simply hand over a file system to the kernel and let it run in a sandbox. I hope that is a definition that makes it a little bit clearer. So I have said Kubernetes is a unified environment. Although you can run Kubernetes on pretty every device, so even on embedded devices like Raspberry Pis, you need to be sure, if you develop a software for an environment, that you don't have to take care on where that is running. So that means when you develop for Kubernetes, you have a certified Kubernetes cluster, which, for example, the GKE is the Google Kubernetes Engine is a certified cluster. Amazon EKS is providing certified clusters. Azure is providing certified clusters. Also, the distributions that I've listed before, Rancher, even if you take your own machines, you can have a certified cluster there. And with that, you can be sure that if you develop something on your Minikube, which is also a certified Kubernetes cluster, you can be sure that if you deploy that into another cluster, you will find pretty much the same features. And with that, Kubernetes can be considered as an abstraction to all the cloud vendors. And that makes Kubernetes very valuable. In fact, Kubernetes is the most active open source project, except for one. The only other the only most active open source project is the Linux kernel, and then there is Kubernetes. So that hopefully gives an impression how vibrant the ecosystem and the community around Kubernetes is. Again, it is very important to understand for a cloud strategy. If you build on top of Kubernetes, you have an abstraction on the cloud vendors, and you don't need to be worried that you're locked into the vendor's offering. So I have said that there is a rich ecosystem. First of all, there are a lot of applications for Kubernetes. I mean, basically, you can take any Docker image and toss it into that. However, applications are usually more complex than just a Docker image. They consist of often of multiple Docker images, and a database is a lot of configuration. What you can get here is, and therefore I'm sharing here one offering. Kubernetes comes with a package manager called Helm, and that works pretty much like the package manager on your Linux box, or even on your phone if you install something from the App Store. You're actually using a package manager, and the same concept works also for Kubernetes. This is, for example, a repository from Bitnami, and there you can choose between all the applications. You can simply take a package here from WordPress, or everything that you find here. You can say simply Helm install Jenkins, right? And then you and that's more or less all it takes to have a full-fledged Jenkins server running in your Kubernetes cluster. Again, it doesn't matter where it is. Of course, Jenkins doesn't work well on Raspberry Pis, but if you have your bare metal machines or you run it in the cloud, you get pretty much the same experience. And that is like OwnCloud here. And that is very important to understand, that we have here a very, very rich ecosystem. And that is just the offering from Bitnami. Everybody can host its own repository. You can host your own repository for your own software. If you're an enterprise and you don't want to publish your software in the internet, you have your private repository here, for example. So another important part is the developer experience. And if I'm not going to mess up my time here, I will show you how to actually develop an application and deploy that into Kubernetes. For that, we have a Cloud IDE. Actually, it is an IDE plugin. That plugin works with Visual Studio Code or IntelliJ, which I prefer to use for coding. Actually, I use both of them. And that makes it very easy to start with Kubernetes and to deploy your own application. So let me first explain a little bit about the concept of Kubernetes. Kubernetes has the concept of pods. So as we said earlier, we deploy Docker containers. Docker containers are actually processes inside the Linux kernel. You start one process, that process can spawn child processes, but basically you start one process, for example, a web server, Nginx or whatsoever. And that can start then its child servers. And that is the Docker container. A Kubernetes pod is in its smallest version one container inside of a pod. However, usually you also need a file system. You can have the immutable file system in the Docker container, but sometimes also you need to write data and persist the data. Whatever you have in the Docker container is fixed there in the file system, and that won't change, but the Docker container itself can mount an external file system, and that is what is here shown as the violet cylinder here that should represent the file system. And however, you can also have two containers running in one pod. Usually you do that only to support your main container. For example, I have one application, and I have a microservice, and that microservice doesn't care much about SSL or authentication, etc. And therefore, you can deploy a so-called sidecar container, which is just another container which helps the main container. That takes, for example, all the traffic and acts as a reverse proxy, for example, which is then routing the traffic to the actual user container. That shouldn't be too complex because this is all running on the same machine. These are the smallest entities. Pods, you shouldn't create too big pods. Actually, you should rather create smaller pods and then replicate them. Another concept for a sidecar container is a container that is taking the logs out of that container and ship them to somewhere to another central place like Elasticsearch or Prometheus, you name it. So that if you write your application, you don't have to take care of the logging. You just log to standard out and let the sidecar container scrape this information. That's for the pods. Again, a pod, a Kubernetes pod, is the smallest entity. The normal case is you have here one container inside of a pod. It is important to mention that every container inside of a pod can share the same file system, and they have all an IP address to the external world. So if these two host containers want to talk to each other, they basically speak to local host. They just need to have a different port, right? And they can mount the same file system. That is important to understand. So in the Kubernetes world, Kubernetes is therefore to take care that your workload is always up and running. So let's say I deploy a number of pods into the Kubernetes cluster. And as I've shown earlier, Kubernetes is built to run on very unreliable hardware. That makes it, for example, easy to use preemptible machines from Google or Spot instances, so that you can say, okay, I can take the unreliable machines, which can be taken away from me. Preemptible machines are very ephemeral machines. They last maximum up to 24 hours, but they can be taken away from you at any time. These are more or less spare machines that Google has there to fulfill some service level agreements. If something has to scale out, then they take these preemptible machines away from you. But on the other side, you can get another machine. So therefore, I'm also running production workloads on preemptible machines where I don't have stateful applications. I wouldn't run a database, for example, on a preemptible machine. However, what I can rely on is that whenever one node goes away, I have here in this example, I have 8 pods running. And if one worker node goes away, be it just because the bare metal machine dies or the preemptible machine has taken away from me, then Kubernetes takes care that these remaining pods are started on the other machines. And what you also have inside of Kubernetes is load balancers, which are aware which pod is healthy and they route the traffic only to the healthy pods. So that means you usually have multiple replicas of a pod, and you tell Kubernetes, don't start them on the same node. If a node dies, the traffic will then be routed only to the healthy pods. Also, if a pod is unhealthy because you have some problems inside of the Kubernetes container. Kubernetes detects that when provided you implement the right hooks, so that Kubernetes can understand what how the pod is doing that. These are the so-called health checks. Kubernetes needs an endpoint where it asks, hey, pod, are you healthy? That can be an HTTP endpoint that replies with an HTTP 200. And as long as the pod is replying to that request from Kubernetes, Kubernetes know, okay, that pod can take more still traffic. If it stopped doing that, then Kubernetes assumes this pod is unhealthy, and it will route the traffic to the healthy pods and eventually kill that pod. So demo time. I can answer some questions in between if you like, or I can continue with the demo of Cloud Run, if you like.
Well, I suggest that we should proceed to the demo and put the questions to the end.
Okay, fair enough. So I take my IntelliJ IDE. So let me start a new project. That is here. I take Cloud Code for Kubernetes. Let me take the guestbook. So that is an example. Yeah, that is. It is asking me here about the Docker image. So when I want to deploy something in Kubernetes, I need a Docker image. So that means when I'm developing here locally something, I need, as soon as I'm done, I need to package that into a Docker image and push that to the container registry, which is a storage for Docker images. And Kubernetes has access to the registry and can pull that from there. So I call it devfest, and yeah, where's the best place for that? Content root. Well, let me put that into temp. So actually, I was expecting here a little bit more. It's always the fun with demos. I think I've messed it up when I have changed the path. Okay, let me close that. So let me start it again. Okay, project location. That's where I have broken it. Would you like to override it? Yes. Okay, here I got my code. I have here a backend, which is written in Go. Okay, I should set up root. That is also a front end, which is template, etc. However, I won't go too much into detail into what here the code is. It is important for me. I have here a set where I can start with, and what I would like to show is how I can deploy that to Kubernetes. So let me edit that. So if there is anything important to set, I have here the container registry. I have here my current context. That means I can have multiple clusters and log into the clusters respectively. It's pretty much a login. So currently I'm here in my demo cluster. So, and then that is okay. Let me start that to Kubernetes. What it will do is it will build the source code. It will build the Docker image and will then deploy that into Kubernetes. Oh, okay. It is already starting here my pods. That was faster than I expected. So what I need to wait now is for the load balancer to become ready. So what Kubernetes does is I can create inside the cluster a load balancer, and it will talk to the cloud API to provision a virtual load balancer and to get my also my IP address. So, and let me access that. So, and with that, this is my new guestbook. Do I have here a chat or something like that I can share with you? Well, probably not. I can put in here my name. Hello, dev first. So I post it here, and what will happen is Kubernetes has deployed for me a MongoDB, and these messages will be stored into MongoDB. So that means my my guestbook can store a lot of messages. I can scale out depending on the load. Kubernetes can create more replicas, and it can also scale it down again. So that means depending on the load, Kubernetes is scaling down and scaling up the replicas that I need here. Yeah, that is a deployment. What I can also do is I can debug directly on Kubernetes. I don't even need to run my my workload here on my local machine. I can use the cloud right away to deploy my workload and debug. So let me try to do that. Therefore, I need an entry point. They must have a handler. Yeah, that looks good. Listen, handle. Let me set here a breakpoint. Since I've stopped it, all the workload is gone here. So what I do now is I will start it in the debug mode, and hopefully it will create the new pods. And when I create a request, it should trigger my breakpoint. So let us wait for that. So everything is running now. I still have to wait for the load balancer. Oh, okay. That is still pending. Okay, there we go. So I have, since the old load balancer was gone, it was really entirely deleted. I get a new IP address, and if I hit that, hopefully my IDE will tell me, okay, there is a request for that. Probably not, because maybe there's something in the cache. Okay, that was probably at the wrong place. Okay, then I need to set my breakpoint somewhere else. No, that is the error. Okay. Yeah, sorry. That is for that I would need to understand which where the application lives. So therefore I skip that. Or what I could do is I do that on a more simpler application where I understand it a little bit more. So that is for the development. So as I said, you can really deploy that on the cluster in a more simpler. Or maybe I should. Oh, that is okay. Yeah, sorry. That is always the beauty with the demos. I would also like to show you something else. I stop here everything, and this will go away. What I would like to show you is how easy it is to deploy applications into Kubernetes. Therefore, I will take something from Bitnami. As I said, I can add here repositories to my Helm, and I can pick here WordPress. So this is how I install WordPress on my Kubernetes cluster. I simply say Helm install. I give it a name because I can install multiple instances of WordPress. And this one I call devpest WordPress. So, and then I deploy it. And what you will see here is that it again start everything for me that I need. Here it starts a MariaDB, and it starts the web server, and it creates services. Services is something like an DNS entry inside Kubernetes and also a gateway to the outside world. It is a networking object. Actually, it is software. It is a software-defined network, and there is a crash loop. So I can, out of curiosity, actually, sometimes sometimes it needs a little bit time to spin up. What you can also do is, what I'm do now is I look into the logs. Okay, get logs f. So let's have a look at okay. And let me describe that. Okay, I've tried that 50 minutes before this this talk, and there it was working. So then let me delete that again and let me try it again simply. So maybe that helps. So what I'm doing now is I tell the package manager to delete that. Then let it start again. If you like, in the meantime, we can also answer some questions in between now, if you like.
Yeah, well, just to explain a little bit to the audience. So Kubernetes has a lot of similarity in like a concept to RAIDs, or the hard disk RAIDs, right? When they were first introduced, because there was so much data you had to store, you couldn't just use reliable hard drives, you had to use unreliable as well, and have to do with that somehow. And now we are facing like similar challenges by not having enough of processing power. That is that is like a good bare metal processing power, and we have to rely on a, let's call it, less reliable processing power, and therefore we have to deal with the challenges of using it, keeping it running, even if something fails, keep it moving from one thing to one hardware to another hardware, and to keep it balanced, because usage is also spikes every now and then. But it all comes from the problem that we are not having enough processing power for our peak usages, right?
Exactly.
So just want to know your opinion. What is about to fail us next?
So first of all, let me say a little bit to RAID. Yes, Kubernetes is adding redundancy. It is you can really add here. Say that Kubernetes is a RAID for compute, because what we need is we need to react on peaks. For example, during the Corona times now, everything has become very unforeseeable. The airlines, they unfortunately now need less compute power. Online stores, they need more compute power. Conferencing systems like here StreamYard, etc. They are booming, and with Kubernetes you can react on that. You can simply plug in new hardware, and it will be consumed directly from the cluster. So what's next? I think Kubernetes has already become boring in a positive way. That means it is very reliable. It is there already since 6 years. I'm operating that at a British telecommunication company, which is very well known, and at a Swedish furniture company, they rely their workload on that. So what's next? Next will be building on top of Kubernetes. I have mentioned, for example, Knative in the beginning. So Kubernetes is a very low level, and next we will see more things evolving on top of Kubernetes, like Knative, where you have a serverless platform that has become a standard. With Istio, you have service meshes, and I think the ecosystem that I've presented, that will more and more evolve. There will becoming more software that can be run on Kubernetes.
Thank you. So Sarik wants to know how to control the security. How is it implemented in K8?
Kubernetes itself is not very secure because it focuses much on deploying your workload and running that workload. That doesn't mean you cannot operate a Kubernetes cluster in a secure way. That just means you have to take care of it. Kubernetes has the concept of network policies, which is which is actually IP tables on the nodes, where you define, okay, this pod can speak to another pod. That is one security concept. It has pod security policies, which makes sure that you run only secure software, but you have to configure that. That means by default, Kubernetes is pretty open. Therefore, it is advisable that you use a managed platform like the GKE, where you have a network where the nodes are in an isolated network, and which is already quite hardened. And on top of that, what I usually do for production workloads, I use Istio. Istio is adding another security layer on top of Kubernetes, where the pods are talking to each other with mutual TLS. That means each pod has to present a service certificate, and the calling microservice has to present a client certificate. And with all that, you can operate your workload in a very secure way. However, as today, you need to have some knowledge. That is not because Kubernetes is complicated. It is because your use case is usually very complicated. Therefore, that to operate something in Kubernetes requires quite some knowledge. Getting started with Kubernetes is easy, but then you need to understand all the concept of network policies, pod security policies, OPA rules, for example, which is also another framework to make sure that the pods are not violating that. I'm also operating quite some large clusters for the mentioned telecommunication company. We have there more than 10 countries operating this, their stuff in the same cluster. There are also subcontractors working on the same cluster. So that means you have a lot of people who have access to that cluster, and you need to apply security there thoroughly. You can operate it securely, but you need to know how.
Okay, thank you. And also, there are several cases where I have seen, at least myself, companies that are not using Kubernetes in their production environment. And I would separate them into two groups, like those who are afraid of it and those who are underestimating it, because they yeah, we know we have like hypervisors and everything else. It's kind of running, so why should we? So let's talk about the first, those who are afraid. Mostly that's because they either haven't tried it or haven't felt the actual benefit, and they don't know when to start implementing Kubernetes into their process. What would you suggest? Like, if I'm developing a new application, like not using some that's already made, but if I'm developing something new, when should I start using?
So I can confirm these cases. And I've actually onboarded a lot of companies to Kubernetes, and my recommendation is always it is important to onboard the people who are supposed to work with that. The most important thing is to understand Docker. And yeah, my recommendation is to get your fingers dirty, right? You need to provide people with the right tools. It is, for example, what I've seen often in enterprises. They are providing the people with Windows laptops, and where these are as locked down that they cannot even start a Docker container on it. And that makes development very difficult for the developers. And I've seen a lot of friction because the developers are not provided with developer laptops. So my recommendation here is to provide at least virtual machines with Linux, so that the developers can get their fingers dirty, that they can start writing their code and putting that into a Docker container and then starting that into Kubernetes. And then you have a learning curve, which is yeah, quite okay for the people. They need access to Kubernetes. Often I've seen that companies are saying, okay, we have ones are the developers and the other ones are the operators, and the developers should develop and the operators should take the code and ship that into Kubernetes. That is not working so well, because you always have a very high latency between that, because developers have no notion about what happens inside the cluster. They don't know how to work with memory, etc. They don't know how to take care of startup times, etc. Therefore, DevOps here is the key to success, to have everybody together and to grant everybody access to Kubernetes, at least to a development cluster. It is okay to have a prod cluster where you have a limited number of people who have access, but the developers must have access to Kubernetes. Otherwise, you will lose a lot of time.
Well, since you mentioned developer laptop, and we've heard that Apple laptops and computers are shifting to IRM in the near future, like there are implementation of Kubernetes that run on IRM platform, including Raspberry Pi. But do you think we are going to face some problems anyway with adapting to new hardware environment, to new architecture?
What do you mean of hardware environment? Hardware environments for Kubernetes or for the developer laptop?
For the developers that are going to use Apple computers with IRM, that is like way too fresh, I would say, since it's low level.
I don't think so, to be honest. First of all, if you work on a Linux machine, you can start your Docker containers natively. On Mac and on Windows, you do that in a virtual machine, and I'm pretty sure the vendors Microsoft and Apple will take care that you can start it. Apart from that, to interact with Kubernetes, you need the shell. As you've seen, I was using the shell. The command line tool here is very lightweight. It is written in Go. It can be compiled to literally anything. It is actually, in essence, it is just an HTTP client which talks to the Kubernetes API over the network. So that means you don't have any real hardware requirements to the developer laptops. You more have a software requirement where you need to have access from your machine to the Kubernetes cluster. Because the problems that I have described was more on the network level, where the networks are so tightened, and also it was often asked, why should the developer have access to Kubernetes? They should write their Java code, and that should be then operated by someone else. That is more, I think that the friction here is more on the mentality, not necessarily in the hardware.
Okay, thank you. And questions from Jamshid. So do you have suggestions on where to start? Because, you know, back in the days, there was a problem that it's hard to find the source because there are so few, and now it's probably hard to find the source because there are so many, and you don't know who to trust. So what's your opinion?
I know there are a lot of books out from Pact Publishing. I think it's Mastering Kubernetes, etc. That is one book. Personally, I must admit, I have never read a book about Kubernetes, to be honest, because I started with Kubernetes when it was in version 0.6, and there were no books back then out there. A good starting point is Kubernetes.io. There you get a lot of resources, very good explanations. There, everything is very well documented there. And also, if you simply go to the GCP console and start a GKE instance, there's also already a lot of explanations. So the easiest way to get started is simply go to the Kubernetes engine and follow the steps there, and also on Kubernetes.io. Also, a lot of YouTube videos are around that. I think Kubernetes is widely adopted. Apart from that, I'm sorry that I cannot recommend you a particular book, because personally, I've never read one about Kubernetes.
Yeah, right. It all usually comes down to practice first, right?
Yeah.
Because the more you practice, the more you understand, and the understanding is not similar to knowledge. And could you share your insights on anti-patterns of implementing Kubernetes? Because, well, for instance, I've seen situations that, well, it's not the anti-pattern of Kubernetes implementation itself, but more about management, I would say. But I've seen where, like, DevOps team is going head first into new project, and they are implementing the infrastructure and creating all the pods logic of their connection between each other, even before software architectures jump in. So they kind of run the show, and then the software developers have to follow them, which sometimes leads to some problems. But I'm sure that you have seen more interesting cases on how not to implement the orchestration.
Yeah. First of all, it is not only about the orchestration, right? The biggest problems that you usually have is with the people understanding that new concepts. Yeah, an anti-pattern is more related to microservices. To build two big microservices, or to build two small microservices. The first case is the more common case, that you try to build a microservice that does everything. If you want to be successful on Kubernetes, you should write your microservices in a way that where Kubernetes can scale them. Right? You need tiny entities that can be spread over the cluster. If you build a big monolith, I'm not saying that monoliths are entirely bad, but they are not very good at scaling in Kubernetes. You should build your microservice with one thing in mind. A microservice should one thing and do that thing right. For example, I'm currently working on a project where you can create PDFs, etc. There is one microservice which takes fully care of creating a PDF. It exposes an API where you put in some data and where you get back that PDF, and it does nothing else, right? It doesn't take care of authentication, doesn't take care of logging, etc. You should write the microservices in a way where you really tailor them. First, a microservice should be not bigger than the team can maintain. One team should be able to maintain one microservice, and teams. By speaking of team size, I mean one pizza team. So that means a team should be bigger than a big pizza can feed. I've seen Scrum teams with more than 20 people. That is not working, right? You should have smaller Scrum teams, and the size of the microservices is very highly related to the number of people who are working on that. And that is one anti-pattern that I've seen. Too big microservice. There's too much functionality in that. Use an API. Use a REST API, a gRPC API, and let the microservice be specialized on what they're doing. And continuous integration is a very, very important part. Another anti-pattern is that people are working for weeks and months on their microservice, and then they start deploying that into the Kubernetes cluster. They develop their huge software, and then they try to deploy that. You should start creating a stub of the microservice, deploy that, evolve that, and then have it continuous deploy. And continuous testing is also very important.
Okay. Thank you very much. And if there are no other questions, do you want to finish the check on the demo environment, or what do you think?
I could use something else. I'm currently astonished that this is not working, because it was working a few minutes before the demo. I must have messed it up somehow.
Don't worry about it.
I'm not worried.
I mean, the whole concept should be quite understandable to the audience, that currently new interactive development environments, they support a lot of these infrastructural applications, and most of them are created by a few clicks. But I would also recommend the audience to understand the things that those clicks do, just in case you have to debug it, because you're going to have to debug it.
Yeah.
Thank you very much for your time.
My pleasure. Thank you for having me.
Thanks, and have a good day.
Likewise. Have fun at the DevFest.